Enterprise architecture has successfully solved identity. When a user logs in, they pass through a centralized authentication control plane. But when we ask what that user is actually allowed to do, that centralized control shatters into a chaotic map of fragmented microservices. We call this space the authorization gap. It is the widening blind spot between a fully externalized identity provider and the actual runtime enforcement of permissions within an application. The cost of this blind spot becomes obvious during an audit. Your auditor asks, who can authorize a wire transfer above $250,000 today? That answer should take 10 minutes. Instead, in most enterprises, answering that question triggers a multi-week code archaeology project. Engineers have to manually trace logic across hundreds of different services, ultimately producing a probabilistic estimate instead of a definitive list. Because authorization decisions live directly in source code, they move at the speed of software delivery, requiring a full code review and deployment for every minor change. Without a centralized policy engine, organizations cannot definitively prove what their systems are actually permitted to do. Authorization decisions do not typically live in a dedicated policy engine. They are written directly into the application code by developers. This means critical security logic is distributed across tens of thousands of individual files, invisible to centralized governance and impossible to audit automatically. We consistently find this embedded logic hiding in 7 recurring patterns. First, standard role-based checks and attribute predicates. Next, framework middleware, business rule guards, and ownership filters embedded inside ORM queries. Finally, feature gates and bespoke legacy policy languages. An engineer reading the code can understand each of these patterns perfectly. But because they are scattered and decentralized, no automated system can reliably enforce or audit them across an entire enterprise. This discovery problem is why EnforceAuth built Zift. It is an open-source, Rust-based command line tool. To handle heterogeneous enterprise environments, the scanner currently supports 9 different programming languages, including Java, TypeScript, and Python. Zift does not rely on simple text searches. Instead, it parses code into an abstract syntax tree. The engine runs targeted pattern rules against this tree, tagging exact nodes with specific categories and confidence levels. Running the scan command outputs a detailed ledger of findings, pinpointing the file path and line number. By scanning the structural logic of the application, we convert what used to be a probabilistic manual guessing game into a deterministic data pipeline. However, rigid pattern matching has a limit. Legacy code bases often contain heavily customized authorization logic that evades standard structural rules. For these anomalies, Zift includes an optional deep mode flag, built specifically to run semantic analysis on complex code blocks. This mode securely hooks into large language model agents, supporting API providers like Anthropic and OpenAI, or local execution through Ollama. When the scanner hits a convoluted business rule, it passes the block to the agent. The LLM reads the raw code, determines the intended access controls, and returns a clean, structured JSON summary of the rule. For strict compliance environments, you can point this feature at a local model to execute the entire semantic scan in an air-gapped environment, ensuring no code ever leaves your local machine. This semantic extraction provides the ability to decipher the unpredictable variations found in human-written code. Mapping the embedded logic is only the first step. To secure the application, those rules must be translated into an enforceable format. This is where the tool's extract subcommand comes in. It takes the categorized findings and automatically writes policy stubs in Rego, the standard open policy agent language. To maintain context, the tool maps the Rego package name directly to the original source repository's folder structure. By generating these stubs, the tool provides a scaffolded starting point for a migration. It allows engineering teams to begin moving from embedded logic toward a standardized, externalized control plane. Once you can see your authorization logic, you can measure it. The primary metric for this is the externalization percentage. This is the fraction of total enforcement points in a codebase that consult a centralized policy engine, compared to those still relying on embedded logic. When EnforceAuth ran its first internal baseline test against a well-maintained modern application stack called EA Financial, the results were sobering. This chart displays the externalization split. Only 20% of the application's enforcement points were externalized. The other 80% were embedded in code, completely invisible to central governance. Establishing this baseline is the mandatory first step for any organization attempting to bring permissions under control. Two external forces are compressing the timeline to fix this. The first is AI velocity. Autonomous agents evaluate data and take actions in milliseconds, vastly outpacing human approval workflows. These machine speed principles require strict boundaries to operate safely. If your permissions are buried deep in legacy code, you cannot effectively restrict what an AI agent is allowed to touch. The second force is regulatory scrutiny over chain of custody. Long-standing frameworks like Sarbanes-Oxley require definitive mathematical proof of exactly what financial systems are authorized to do. Right now, the SEC's new cybersecurity disclosure rules and the EU AI Act are demanding that same level of cryptographic proof for policy intent across all digital systems. Embedded authorization cannot produce definitive decision logs. Defensibility requires a modern, externalized policy engine. To accelerate this transition, Zift was released under the permissive Apache 2.0 open-source license. The static discovery, parsers, and policy emission engines are free to use. Continuous runtime enforcement and compliance logging remain part of the commercial platform. The discovery step is too critical of a bottleneck to hide behind a lengthy enterprise procurement cycle. Every team needs a frictionless way to assess their codebases. As industry standards converge around frameworks like Open Policy Agent, algorithmic source extraction provides the necessary on-ramp to reach a modern, externalized security posture.